So there are some examples, like for example, you have USB or you have Ethernet. Why do we use these interfaces? Basically for the purpose of data transfer. So if you have a laptop or PC and you want to send the control instruction through mouse or keyboard, then you connect through USB, right? USB is the serial communication interface. Or like from PC or laptop, you'll be connecting internet to Wi-Fi. So this is a Wi-Fi interface. So from Wi-Fi to internet service provider, you'll be using some interface like Ethernet, right? Same way, if you have like microcontroller board, or let me consider uh, your washing machine example itself. You have a microcontroller. You will have display. You will have buttons. Motor driver. Pump. Some ADC loop backs, everything. So it has to communicate to the centralized microcontroller. So it has to communicate to this controller. So for that purpose, we have a communication protocol. So it is something like the microcontroller, it's the language of microcontroller to talk to another peripheral or device. So for example, anybody from India, if they want to communicate to the international person like Korean or Chinese, so either he should have intermediate translator if other person doesn't know English, or he has to learn that language and speak to him, right? So that way, this microcontroller and these peripherals will have some common language where they can communicate based on that, like they will configure. For example, if you configure for 45 minutes through buttons, that has to be according to that, like it has to communicate to the pump, motor drive, display, everything. So that is basically happens in um, communication protocol. So we have, like you can see, I mentioned it is a serial communication. We have two types of communication. One is serial and another is parallel. So for example, if I want to send 8 bit of data from point A to point B. I will have various options, like I can use one wire. I can send bit by bit, bit 0, bit 1, bit 2, because when I say bit, either it will be 1 or 0. In terms of voltage, it will be plus 5 volt or 0 volt. That is one way. Or I can have 8 wires. I can send all the bits together, bit 0, bit 1 and bit 7. All the bits together. So that is actually parallel communication. So each communication interface has its own advantage and disadvantage. Here, you have only one wire, so less number of wires. But speed, since we have to send one by one, bit by bit, it is slow. Whereas here, it is 8 parallel interface, speed-wise fast. But what about wire? It requires more pins. more resources. So here, usually for short distance, we use parallel. For long distance, we go for serial. So we have various types of transmitters and receivers, communication mode. One is simplex mode, where either, we will be like either transmitting only or receiving only. Together is not possible. Either TX only or RX only. Best example is your FM radio. So you will be just receiver. The FM transmitter will be just a transmitter. So we have another mode, that is half duplex. So here also one single wire will be there. So either I can transmit or I can receive one at a time, one after the another. So that is half duplex. So I2C interface is one of the example for this. Third is full duplex. So here I can transmit and receive simultaneously. TX and RX simultaneously possible. Okay. So this is full duplex. Example is your mobile phone. In terms of interfaces, UART, SPI. These are example for full duplex. Next is actually asynchronous.
Sorry, excuse me.
Huh.
It got disconnected by mistake.
When now or like long back?
Now, full. You were explaining, no, full thing.
Full duplex. Okay.
Yeah.
So in the full duplex, what is going to happen? Like we will be transmitting and receiving simultaneously. Like for example, mobile communication, or like there in the mobile communication, we can simultaneously talk like our Zoom communication. So that is full duplex. So here, other in terms of interfaces like your USB, SPI, UART, all are full duplex communication. And in terms of synchronous communication, we have two types. One is asynchronous and synchronous communication. So when I say it is asynchronous communication, okay, first we will come to synchronous communication. So if I just send some data like this, people can interpret in different ways. So someone can interpret it is like 11000011. Somebody can interpret it as 101. So somewhere we should have some reference. That is where along with the data, we send some clock. So here data will be properly interpreted with respect to every edges of the clock. Either it can be rising or falling edge. So here it can be interpreted as 1, 0, 0, 0, 0, 1, 1. So this, like if we send clock along with the data, we call it as synchronous communication. Whereas if I transmit like no clock along with the data, then usually I call it as asynchronous communication. So for this, examples are for the synchronous communication, SPI, that is serial peripheral interface, and I2C, inter-integrated circuit. These are the two interfaces which are example for synchronous communication. Whereas in the asynchronous communication, what I'll be doing is, instead of clock, I will send some reference bit called start bit and stop bit, etc. So for example, in case of UART, I'll send one, initially I'll send one start bit. Okay. So what it does is, like, it will be a transition from high to low, like this. Then I will send the 8-bit data. After that, I will also send something called parity. Parity is nothing but XOR of all this 8-bit data, which helps me to check the error if there is any error. So when I am transmitting through wire, there is a possibility that the bit can get corrupted. So this 8-bit data, I XOR everything. Like for example, 1011, 1101. What I do XOR. 10 XOR is 1, 11 XOR is 0, 01 is 1, 110, 01 is 1, 101, 110. So parity bit is 0. So after that parity bit, I will send one stop bit. So, but one disadvantage here is both TX and RX should know their clock speed. So since here, like, we are transmitter itself is sending the clock, the receiver need not have the knowledge of clock. Here we need to know the knowledge of clocks for properly decoding the data. Okay. In 8050, in UART, one important thing we need to understand is baud rate. So there is two things, two parameters. Usually people will get confused. So there is a difference between baud rate and data rate. So here I said I am sending the stop bit, start bit, parity bit, and data. So here these are actually in that, like, parity, start, stop. These are not actual data. So baud rate is together data plus other overhead. The data rate, I mean the rate at which we are sending data and overhead together. It can be, for example, if I'm sending at 9600 bits per second, then it is 9600. Whereas a data rate is only, it considers data. It will be less than that. Like maybe if I consider out of 8 bit, out of 12 bit, 8 bit is only data. Then rest 4 will be usually overhead. That is 25%. So 9600 into 0.75 will be your data rate. So this important difference you should know. And in UART, we will have like actually like there will be multiple signaling along with that TX and RX, but generally we say null modem connection. What we do, we have 3 lines: TX, RX, and ground. So both the sides, if I want to communicate, I'll have TX, RX, and ground. I will short 2 devices ground. So if I want to transmit from microcontroller 1 or any device 1 to device 2. This TX of microcontroller 1 will be connected to RX of microcontroller 2, and RX of microcontroller 2, RX of microcontroller 1 is connected to TX of microcontroller 2. So this crisscross connection we do, so that like whatever I transmit here will be received by microcontroller 2. Whatever I transmit from microcontroller 2, I'll receive from microcontroller 1. So this we call it as crisscross connection. So usually in DB, we use something called DB9, usually older printer cables and all. So that uses something called DB9 connector. So in that, pin 3 is connected to TX, that is transmit data, and pin 2 is connected to receive data. This is standard actually. I mean, your older printers and all, right? So used with this. So 7th pin usually we connected to RTL. So this is special interface, request to send. Pin 8 is connected to CTS, that is clear to send, and pin 6 is connected to DSR, data set ready. Pin 5 is connected to SG, that is signal ground, same as this ground. And pin 1 is connected to CD, carrier detect. Pin 4 is connected to data terminal ready, DTR. And pin 9 is connected to ring indicator. These are the old interface where with like more protection over the collisions and all. But in general, in industry for the simpler application, we use these lines only. So that DB9 connection, like if you are using any complex application like printers and all, so then we go for that DB9 based design. So, but like most of like in industry also, I have like not much used other interface like other pins. Mostly we use that like first few lines. So what happens actually when the length of cable increases, right? So when I say UART, from the microcontroller, microprocessor or FPGA, it will be 3.3 volts. But when I want to transmit for a longer distance, it can be few kilometers. Okay. Then if you use UART with 3.3 volts, that doesn't work well, because you know the cable itself has some resistance and capacitance. So because of that, it keeps decreasing, voltage keeps falling, and you will not be able to communicate properly. So for that reason, the EIA, Electronic Association, Industries Association, they have come up with the standard called RS-232. RS-232. So in RS-232 standard, what basically will be done is like they'll be converting this UART, like uh, CMOS or PTL logic, like 3.3 volt logic, into higher voltage. Okay, so it will be around like -3 to -25 volt. That is actually 0. Okay, this is 0. If you want to transmit 1, it will be +3 to +25 volt. That is 1. So this usually we call it as RS-232 standard. So usually for this purpose, they use something called MAX 232 IC, MAX 232 IC, which usually used for this kind of conversion. And in UART, right, I said like it is the 8-bit data which we are transmitting. So that generally, for example, if you want to transmit a character A, so it is going to find the ASCII value of it, and that ASCII value will be communicated. Okay. So usually that is 8-bit. So that is about serial interface. So tomorrow we will look into like how we can implement this serial interface using 8051. Okay.
Okay.